In a previous video, we looked at the motion of a car along a horizontal track, or a circular track, but it lays flat. And so our car looked like this from the side or from the back. Okay? And from it, we were just basically able to see that frictional force is what's causing this centripetal or radial acceleration, what's causing it to be able to turn. It was friction. Okay, now I'm going to ask a different question. In that one, we assumed that the tangential acceleration was zero. It's moving at constant speed. But what if it wasn't? What if I ask a question like this? A car starts from rest. Okay, car starts from rest, and so we'll say t0, s0, and b0 t. Okay, so that's its tangential time, or at the time, the tangential position and tangential velocity, and that's going to be 0. We'll start from 0. And I say, if the car accelerates tangentially, so along its direction, this car speeds up at some fixed rate. Okay, so it's going to be going along, and it has some a tangential. Okay. How long can the car stay on the track? Now, think about that question a second. How long can this car stay on the track? Well, the first thought I hope listeners is, well, what would make it go off the track? Okay, the driver is good and can keep the car steering the car, but what would make the car go off the track? If we get over here to this picture, is that there is a maximum speed at which the car can stay on the track. If the car exceeds that, then it slips. That's what we used as our condition. We said that this maximum speed is when the frictional force reaches the static max. If the car goes any faster, it will slip. And so we can take this to a dynamics and a kinematics combined problem and say, okay, so the car is going to get somewhere, let's say right here, at some later time t, t1, some later position, s1, and some later velocity, and that velocity right there would be equal to this Vmax. And so we can treat this as a kinematics problem. So instead of having this being equal to 0, it's not equal to 0. And in fact it's speeding up, so we say that's this way, okay, because that's in the tangential direction, forward direction. Alright, and so with that being said, we could say, I'm trying to find this final time, and what knowns do I have? Okay, let's suppose we know our initial time, we set it to be equal to 0, and our initial position, I've got that equal to 0, my initial velocity in the tangential direction is equal to 0. Okay, let's just suppose I do know this tangential acceleration. I'm not going to use any numbers in this problem, but just we know that one. And I'm looking for this one. I don't know this one. Do I know this one? And the answer is yes, through this process. Okay, so having established this, I can find Vmax. So I'm just going to write V1t equals Vmax. I know that. Okay? I know that. Sorry about that. I know that V1t equals Vmax. So I can use that. And finally, I just need to find my T1. How long before it flies off the track? Okay, so with that, I can think I know my acceleration, I know both my initial and my final time, and I'm looking, or my final velocity, and I'm looking for my time. Well, I can just use the definition of acceleration written this way: V1t equals V0t plus at t1 minus t0. That's 0. This is 0. And I can solve for t1, just the final speed over the acceleration, tangential acceleration, and that is sort of mu s rg over at. Okay. So this is now a non-uniform circular motion problem, but the main idea is I've connected just the necessity for centripetal acceleration and how it's caused by some force. In this case, it was a purely frictional force. If the problem was a banked freeway, then I'd just follow the process again, only now we'd have a normal force helping to contribute to this radial acceleration. And given enough information, we could still solve for an answer like this. And we're going reverse order. Say after 4 seconds the car flies off the road, what's the frictional force? Well, we go backwards and find that. So this is a cool example of how we can take one bit of information, new information, and use some old ideas and combine it to solve for a very real problem that a race car driver would probably want to know if they're trying to accelerate at a constant rate.